Boom, that's it.
Hi, everyone. I hope you're all doing well today, and happy to see all of you here in Madrid. So this is my first YOLO Vision, and I believe I have some interesting stuff to present to you. And I'm going to start talking and explain about AI PC. I hope you already heard about that, but let me give you some introduction to that, because it's a very new device category which just appeared on the market last year. And we are going to talk about AI PC, about software stack, and how to run YOLO models on AI PC. So first of all, on the screen you can see multiple AI use cases which are relevant for client computing, for the PC. And here we have two categories. First category is conventional AI or traditional AI, and another category is generative AI. So traditional or conventional AI is here already since many years, of course, and you are, I believe, familiar with such use cases like pose estimation, object detection, voice recognition, and so on. And as you know that the use cases like pose estimation or object detection can be implemented using YOLO models from Ultralytics. And we have also a new type of AI use cases, it's generative AI. But everybody knows about that already. So to generative AI belongs such use cases like chatbots, text-to-image generation, even code writing, programming on the PC, text-to-video, and so on. So there is this diversity of use cases, and as emphasized earlier by the colleagues from Ultralytics, such models, traditional AI and generative AI, they're quite different, and the size is very different. So the traditional AI models can occupy, let's say, maybe hundreds of parameters, maybe some million parameters, right? But in case of Gen AI, we have even billions and trillions of parameters for the model. And the point is that on AI PC, we can run them all. So we can run all such models on the AI PC without any cloud, internet connection, and keeping the data private. So what is AI PC? Actually, AI PC is a device, it's a computer which is able to run all such use cases or all such AI models efficient. So I mean power efficient, and also it must be performant, comfortable execution of such use cases. And at Intel, we have a special processor for that, which is called Intel Core Ultra. So we have already two series of two generations of this processor. First one is Intel Core Ultra Series 1, and today I'm going to talk about the Series 200V. And basically, these processors, they have three engines inside. First of all, here in the center, we have central processing unit. So every PC has a central processing unit or CPU, and it's able to run any kind of workloads, and of course, AI workloads as well. And it's okay to use CPU for some workloads if you need to have, if the model is small, and if you need a short latency. And on the this processor, Intel processor, we deliver up to 5 TOPS performance on the CPU. But of course, we have other AI engines, and now one is GPU, graphic performance processing unit. And so it's obviously, first of all, it's for graphic workloads, but it also works very well for AI workloads, and especially AI workloads which require high throughput, especially for Gen AI models. And in the new generation of the processor, we deliver up to 67 TOPS on the GPU. And this is integrated GPU. I am talking about integrated GPU, which is on chip on the processor as well. And of course, NPU, neural processor, it's new unit which is dedicated for AI use cases, and especially NPU is efficient to use for the use cases when you need to run your AI workload in background. For example, YOLO model, object detection. So it runs continuously for a very long time, because the main feature of NPU that it's not only performant, it's also very power efficient, and over the time you can save a lot of energy. And of course, also very important to understand when you work on your CPU, you have a traditional application as well, like Office programs, right? And in the same time, if you run a lot of AI workloads, like, for example, like blurring of your background during the presentation or some chatbots, you don't like to keep your CPU busy with AI. Otherwise, you will get no bandwidth for your just standard work with Office or with browsing. And therefore, it's good to offload AI to the dedicated engines like NPU, for example. And it's possible to do it with OpenVino. And in total, we deliver up to 120 TOPS for the whole system. And as I mentioned, OpenVino is a framework to deploy such models to AI PC, and there are more than 500 models can be used with OpenVino on AI PC, including YOLO models from Ultralytics, of course. And what I would like to show you, I'd like to show you something special. All these free AI engines, actually, they are located in such a small chip, right? So this is a Intel Core Ultra 200V processor, right? And it's very small. All three engines are here. So it's a CPU, GPU, so multi-core CPU, obviously, GPU, and also NPU. So therefore, the hardware design is quite simple for the notebooks. No need to have a discrete graphic, for example. And also we have RAM memory on the chip as well. And this is just a tiny chip. All right. So let's talk a little bit more about the model. You saw this slide already, and basically using OpenVino, you can decide yourself which model to be deployed to which AI agents. For example, object detection with YOLO Ultralytics model can be run on NPU or on the CPU or on GPU as well. You can decide yourself. Also, chatbots make sense to run on GPU because they need a lot of performance. Text to image you can run on GPU and on NPU on the same time to maximize the system throughput, and so on. So it's up to you how to deploy your workloads, and this is very simple. All right, some words before we go to YOLO topic, some words about software stack. And as I mentioned, OpenVino can be used for optimization and deployment of the models. OpenVino stands for visual inference and neural network optimization, but it's not only for visual use cases, it's also for NLP, audio, LLM, Gen AI, transformers, and so on. So basically, any type of model can be deployed with OpenVino. And OpenVino is an open source project with Apache 2.0 license. Can be accessible on GitHub. So how it works? We have multiple frameworks. So I believe you know all these frameworks like PyTorch, TensorFlow, Onyx, and so on. And these platforms, they have own model formats, right? And OpenVino is able to read all these models in these formats and also optimize the models. For example, using quantization or weight compression techniques, so the model can be reduced to very small size. You can imagine in case of LLMs, for example, it's really critical to fit such huge models in the device, in the PC. And when the models can be deployed to CPU, GPU, NPU, or even FPGA on any type of Intel devices, so including Intel Core Ultra, which I explained before, and even ARM. So you can use also OpenVino on ARM devices, and you can use it on Windows, Linux, and macOS. So most of us as developers, I believe, and therefore, before I hand over to Adrian, I would like to show you some code, how easy to work with OpenVino. So if we use Python, so we just install Python package, we import OpenVino runtime, we use some image as an example of input for the model. So when we initialize the OpenVino core, we read the model, so we can read the model directly in the provided format, for example, TensorFlow in this case, or you can take Onyx model. So when we compile the model for the AI agent CPU in this case, but it's totally trivial to change it to NPU or GPU. So it's just this device name. And then we specify output layer and we run inference and get the result. So this is very easy. So this example is with Python, but you also can use, for example, C++ here, which is very important. And also you can use C++ for LLMs model, and you also can use JavaScript and some other languages. With that, so let's hand over to Adrian and start with YOLO.
Yeah, so thanks, Dima. Dima showed us how to run OpenVino in pure way, right, with OpenVino code. However, we work closely since 2023 with Ultralytics to enable OpenVino directly in Ultralytics package. And I'm gonna show you that. So of course, you can go directly with OpenVino code, you can convert the YOLO model and so on and so on. But you have also another way to do so. You can just use Ultralytics package and specify, for example, in command line interface, that you would like to export to OpenVino format. Similar thing for integer version. So integer is a quantized version of YOLO model. And then you just need to specify that integer 8 is the flag of integer 8. And of course, you need to provide also data for calibration process. And then you will have your model quantized to integer version. And I will show it in a moment. Of course, you can do the same in code, right? So you just need to import the package, then you need to create the model, in this case, YOLO11N, but you can go also with YOLO 8 or 5. And then use export function when you specify format equals OpenVino. And in this case, when we specify half equals true, it means it will be exported to floating point 16. But if you want to go for quantized model, again, you need to specify int 8 equals true and provide data for calibration process. But this is export only. What's next? The next thing is inference, of course. And once again, you don't need to go for pure OpenVino code. You can still be with Ultralytics package. And in command line, you just use predict method. When you specify model you would like to run, instead of YOLO V8 or YOLO11N, you can specify the exported model, YOLO11N OpenVino model, and it will run with OpenVino as a backend. Similar for integer version. And also, if you don't have a stream, when you have a video file, when you have all frames at once, you can even specify higher batch. It means that we will run this in cumulative throughput mode when you will use all devices at once. So it will run CPU, GPU, NPU in parallel. But this is only when you have all frames at once and you specify batch higher than 1. Good. How it looks like in the code? Similar. You import OpenVino, you import YOLO from Ultralytics, then you specify the path to the exported model, and you run the inference. And I'm talking about quantized model. Of course, quantization is beyond this speech, right? The topic of quantization. But we also compared how the quantization influences the model itself. Here we have metrics for int 8 and floating point 32 for YOLO V8 X large model. And the original mean average precision is 0.579, but when we quantize that model, we achieve 0.562. Of course, nothing is for free, right? We are quantizing the model. We are changing the precision to lower precision from floating point to int 8. This is a lossy compression, something like that. But the question is it a big deal, like this 0.017? Probably it's negligible in most cases, and the performance should be much, much faster. So I recommend you trying that. And of course, we are talking OpenVino here, OpenVino there. What about performance? You need to check it yourself, of course, on your computer, because it depends on the hardware. But on the right, you have QR code. We did official benchmarks with Ultralytics, and you can scan the QR code, go to the documentation page, and you will see how YOLO V8 is running with OpenVino. And if you want to do the same on your computer, go for the benchmark tool or run in code similar as you do for other stuff. So it looks like this. I recommend you to try that. However, I'm also going to show it live right now. Good, so let me switch to the demo. You cannot see that, no problem. We will make it visible. Good, I'm going to run one of our demos, which is called people counter, because we are going to count people there. Of course, using YOLO. .11. So let's see what performance we can get. Good. Running in the background, you can see it's detecting me. That's super cool. But we are here to talk about... Yeah. He is also probably a person, that's why.
Yes.
But what's important here, the performance. You can see performance in the right corner, in the top right corner. We have 36 frames per second running floating point model on CPU. But let's switch for GPU. And this is not Series 2, as Dima mentioned, as Dima showed you, the newest, latest CPU. This is just one generation back in this laptop. And we still have 100 of frames per second running on integrated GPU. So this GPU is not a discrete card. It's on the same chip. And what else? We can go for back to the CPU, and I'm going to switch to integer version. So right now we are running quantized version, and look at the frames per second, 70 frames per second, just changing from floating point to int 8. So not only hardware, but also software optimization is quite important. But I'm showing you here our previous generation, but we have also the latest generation, not only in his yes. Pocket. No, we have there in our booth. So after this speech, please visit us there in the corner. We have that device there with the latest CPU, and you will see how fast it can run on CPU, GPU, and NPU. And you will be surprised, I promise you. And not only, please visit us not only for, I need to exit this. Yeah, not only for seeing the performance, we have also some nice swag to give out. So And so the demo I showed you is open source. If you would like to try at your home, scan the QR code in the corner, and you will run on your computer. You will see the performance. It doesn't have to, be an AI PC, right? It can be any Intel hardware. It can be even in cloud, if you have access to webcam, for example. But your laptop, 8th generation, 10th generation of CPU, it will work, right? So this is the first demo. But we also created something what we call AI ref kits. One of them is intelligent queue management, when we count people in some specific areas, when we can, for example, count people standing in queues to the cash desk and so on and so on. So if you would like to learn more, Scan the QR code here. There is a lot of materials like articles, videos, specific code with the explanation how to run this, and so on and so on. So you will learn more. And I gave a speech a year ago about this project. So if you are interested, I think it's still on YouTube, so you can go there. And now it's time for a bonus, and Dima will show you how to run Gen AI.
All right. So we have not only slides, but you can see we have also several demos, and this is AI PC. And I would like to show how paint your dreams on AI PC. So I hope all of you have dreams. I have a dream as well, so I will share to you later. But we go here, right? One. Okay, so this is our demo, and by the way, before I start the demo, we actually have all these demos materials online in GitHub. You can see our Open Build and OpenVino Build and Deploy repository. So please feel free to clone and try these demos, and one of them is paint your dreams. So it's here, and I already started it. So it is implemented with Gradio interface, and we have already some predefined dreams. Also, we selected that we run it on GPU, and let me start generation here.
Oh.
So I think I need to restart it. Just give me a second. All right. So it's started. Just a second.
Ready.
So one more try. So let me set up the parameters one more time. I select GPU. Here I generate endlessly, and I will take this prompt. All right. Now try it. Start generation, and I can see. Yes, you can see that it's compiled on GPU, and if we go back, so we have this dream. So I live in Bavaria, so I would say it looks quite similar, nice mountains, and it's generated right now on this PC. You can see also how much time does it take. And you can see other dreams. I believe Adrian has implemented this demo, so this is maybe dreams from Adrian. And let me try with mine. So I can show tapas in Madrid, for example. And let's see what it will generate.
See that every 3 seconds you have new tapas.
Yes. So and actually I realized my dream yesterday. So with that, thanks a lot for your attention. If you have any questions, please feel free to ask.
Fantastic. Thank you, Adrian Boguszewski and Dmitriy Pastushenkov. Very, very impressive. Do we have time for questions? I don't think we do. The question cube is running up the stairs, so I think that is a no. So listen, thank you. That was absolutely fantastic. Those dreams are exactly like mine. Maybe a bit less Guinness, but you know, very impressive.